Hi everybody, we're delighted to be here today to talk about the application of AI and data analytics. From road safety, crowd monitoring at airports, through to reducing 4 days of work into 4 minutes, we're going to talk you through real-life applications of AI and data analytics that are being used today. My name's Jennifer Liu and I work for InvestNI, the economic development agency for Northern Ireland. Today, we're lucky enough to hear from 3 innovative Northern Irish companies about how their customers, major public and private sector organisations, are utilising AI and data analytics to enable them to do things faster, more easily, or simply do things that they just could not do before. So, introducing our panellists, we've got Philip MacLeese, co-founder and CEO of See.Sense, the intelligent bike light with RoadSense. Stuart Mills, COO of CrowdVision, automated people tracking using video analytics. And Dr. Alistair McKinley, CTO of Analytics Engines, the data analytics solution providers. And without further ado, let's hand over to our first panelist and case study. Over to you, Philip, from See.Sense.
Thank you, Jenny. So the big question that I'm going to answer for you today is, why does a bike light need artificial intelligence? And I'll do that by taking you through my journey and where it started and where we ended up, how we ended up with the opportunity to use AI. So the average cyclist actually commutes to work in an environment like this. And I was in client-facing technology based in Asia, and I have a very similar story where I was a busy executive and didn't have much time to go to the gym, so I took up cycling as a way of getting a bit of exercise into my daily routine. Fed up with daily misses on the roads, I wanted something to improve my visibility, to help me stand out and give me better safety. So I looked at the accident stats online and saw that more than 2/3 of all cycling accidents occur at or near road junctions in urban areas and during daylight hours. And I also realized that a lot of the cars were getting daylight visible running lights, and that's because of European legislation since 2011, because it reduces vehicle-to-vehicle collisions by around 5 to 10%. And so I figured if something as big as a car needs it, then me and a bicycle, I'd absolutely like that as well. So I started out with very bright lights, which were bright enough to be visible in the daytime. They were actually mountain bike style lights. And they worked really well. They gave me the presence on the road. They gave me a better experience and a much safer journey. But the downsides were they were big and bulky and they're expensive. So you don't want to leave them on the bike because they can be stolen. And you don't want to take them with you because you get these big battery packs and wires and it's just not convenient. And so I was cycling along one day looking at the smartphone on my handlebars, and I realized that it had a level of situational awareness. It knew from its sensor systems where I was going, a little bit about the environment around me. And so I thought, what if we took the smart sensor technology from the mobile phone and we integrated it into the backlight to give it the situational awareness? Then it can flash brighter and faster in situations when I need to be seen most, such as roundabouts, road junctions, filtering in traffic, and so on. And it can conserve energy and flash more conservatively, and I guess a little bit less bright whenever I'm not in one of those situations. By doing that, we can reduce the average energy consumption, make it still daylight visible, but make it a much smaller, more convenient device. And so I relocated from Asia back to Northern Ireland, where I'm originally from, set up the company, and we began to develop this idea. So one of the challenges that we faced, we imagined to begin with that we would use a lot of algorithms to work out when you were at a road junction, a roundabout, and so on. But what we realized is that there were just quite a lot of variables. Just thinking about bicycles, not only have you got all these different styles of bicycles, but you've got different tire widths, tire pressures, frame materials, and so on. And each of those requires different calibration for the device in order to make sure that it reacts well, but not too much and not too little. And much more than that, we realized there were so many other things that we had to layer on, understanding the rider's experience and how they were reacting to the environment, understanding what the road surface was like and how that factors into the experience, and even looking at things like light levels to understand were we cycling in the daytime or the evening, and of course what the surrounding traffic was doing as well. So we realized that in order to crack all of this, it wasn't going to be a basic algorithm. It would have to be AI, and we would have to run the AI on the device itself. And that's precisely what we did. So we used a neural network running bare metal on the edge on the device to give it never before seen processing capabilities. And that allows us to profile a number of things. So first and foremost, we profile the cyclist, understanding their level of experience. And that's purely because if you are an experienced cyclist, you'll typically look much further ahead, anticipate further, and so you'll give less clues in terms of your input, your braking and steering and so on to the light to allow it to react to those situations. And on the flip side, if you're a relatively new beginner cyclist, you're going to be relatively abrupt with your inputs. And again, the light could be overreacting. So we profile that to make sure that we get it right. And so that allows us to do some really, really clever things. We discovered through testing that in 83% of cases, we can identify when a car is approaching from behind. Now, we don't have any direct sensors that can measure that car's approach. What we're actually measuring is the reaction of the cyclist. So the AI, when it's sufficiently tuned in, will identify that you as a cyclist are subconsciously slowing down to allow the car to pass, or subconsciously going a little bit faster in order to try and sort of outrun the car, or to reduce the relative speed of overtake as that car passes you. We realized as well through testing that as we were working through with a lot of this data, there was a massive amount of it that had practical applications for use in better design and planning of our city's infrastructure. And so we opened it up to the crowd and we said, if you'd like to opt in to help your city, we can aggregate all of those useful insights and data and telemetry that we're gathering from all the bikes to give never before seen insights. And so this is a lot more than just where people go. This is understanding about how they go there, what their experience is like, where they're having issues. And it really does show up the things like the pros and cons of infrastructure and does it really work? So we did a project where we looked at some of the bridges across the rivers in London, and we saw that there was actually a better cycling experience on bridges which had dedicated cycle lanes, which of course is no surprise. But what we did find, which was perhaps quite surprising, was that where you had a defined cycle lane and the cyclists were constrained within it, when you had a set of traffic lights at the end of that, you would get congestion and bunching of cyclists. So on a normal road, they can move out and expand and use the full width of the road, the advanced stop line, and you'll get a lot of cyclists through on each change of the traffic lights. But where they're constrained to a cycle lane, they're perhaps only 2 or 3 abreast, and so much fewer number of cyclists can get through at each change of the traffic lights. In Dublin, we saw a really interesting piece of infrastructure. So there's a lovely road with cycle lanes and nice centralized segregated lane down the middle, so there's no cars crossing left and right. It looked absolutely perfect from a design perspective, and everything indicated that it should be a wonderful piece of infrastructure. But what we saw was that there was actually quite a lot of interactions between the cyclists and the pedestrians. There were restricted sight lines around St. Stephen's Green as people came out from between quite thick hedges onto the road, and they would often step onto the road, perhaps not hearing the cyclist coming because they were on their phone or otherwise distracted, which was a really useful insight on infrastructure that should have been really good. And then we've also seen most recently in Oxfordshire, where they've looked and profiled pre and post-COVID cycling to understand what's happening. And things like cycle counters will obviously identify changes in numbers of cyclists, but what we were able to identify was that there was actually a change in the types of cyclists based on their experience levels and also the types of journeys that they were undertaking. And of course, it doesn't stop there, because most cycle tools, indeed a lot of what we've done to date, has focused on trends from historical data. Indeed, the most used tool in the United Kingdom relies on census data, which is now nearly a decade old. So we're using AI in a second layer to take this to a whole new level. We're using intelligent actors, which are trained to behave differently. So all of that really interesting telemetry data, we're using it to create commuter cyclists, enthusiasts, leisure cyclists, food delivery cyclists, cargo bikes, and more. And then what we're able to do is put in things like roadworks, new cycling infrastructure, and we can see how those actors interact with that infrastructure to allow planning at a level that has never been seen before for cycling. Thank you.